Welcome to Let's Calculate Something. Today we're going to do some calculus. We're going to do differentiation using the product rule, talk a little bit about what the product rule is, and then I've got three different examples for problems on the product rule. So we'll kind of start with the intro, and I'll erase the board and I'll put up each problem and we'll solve them. So the product rule says if you have two functions in x equal to y, define the derivative of y with respect to x, which we write as y prime. You do derivative of x times g of x, derivative of f of x times g of x, plus f of x times the derivative of g of x. So we're going to apply that to these three different problems, and let's see what we get. Okay, so applying the product rule to x cubed times cosine x, we will define x cubed of f as f of x. We'll define cosine as g of x. And then we'll start to work the problem. Now, before we do that, I'd like to invite you to subscribe to my channel, please, and hit like if you like this video, and then also it'd be great if you could add a comment and then hit the little bell so you can get notified as we put up more videos. As you see, the channel's starting to build some steam, and I'm going to have quite a few different videos that are being posted. So let's get into the problem. So y equals f of x g of x. So y prime equals f prime of x times g of x plus f of x times g prime of x, where the prime is the derivative. So let's work the problem. X cubed is f of x, and cosine x equals g of x. So f prime of x is going to be 3x squared, and g prime of x is going to be minus sine of x. So we now have all the pieces we need, so let's plug in. So we have 3x squared times cosine x plus plus x cubed, right, times this, which is minus sine of x. All right, so now that is going to equal 3x squared cosine x minus x cubed sine x. And that's our answer. If we go to example 2, this one's a little more complicated because we're going to add a third function. Okay, so what I did is I highlighted what we had before, but I added the third function in red. So if we add the h of x function, then we just continue with the product rule. We just have 3 terms instead of 2, and we have the h of x multiplied by the first set like we had before, and the h of x multiplied by the second set like we had. And then we have to take the derivative of h of x and multiply it by the first 2 functions. That's the third term. So in this case, we have x squared e to the x log x as our function. And so if we want to take the derivative of each piece, which I assigned here, we'll get f prime of x of x squared is 2x. G of x is e to the x, sorry. And the derivative of that is actually e to the x. It's the same as it is. That's the interesting thing about the exponential function, is that its slope is equal to its value everywhere on this curve. And then h of x is log x, and the derivative of log x is actually 1 over x. Okay, so now we have all the pieces to fill this in. So we get y prime is going to equal f prime of x, g of x, h of x. So that's 2x, ex, ln x. And then the second term will be focused on differentiating the g of x, which is f of x, which is x squared, right? Which is here. G prime of x, which is e to the x. And then h of x, which is ln x. All right. And now we have the third term where we're going to take the derivative of the log x, which is 1 over x. So we have x squared, e to the x again, and then 1 over x. And we can simplify this a little bit. We see that we have an e to the x as a common factor. And then we can see that this 1 over x will cancel out the x squared, so we can get rid of that. So we have e to the x of x. So factoring out the e to the x, we get e to the x. Actually, we also can factor out an x. We have an x in each one. So x e to the x equals, or times, 2 log x plus x log x because the e to the x came out, and then we take the x e to the x, so we have plus 1. And that's our answer. So it's just a little bit different with 3 terms. But it's just carry on the product rule. If we had 4 terms, we do 4. It's pretty simple, just the product and the sums. And now you have a second example, the product rule, a little more complicated. Okay, so for our third example, we have trigonometric functions multiplied by together, sine x and tangent x. And so when we take the derivative of each part, f of x and g of x, assigned like our problem statements showed, we get f prime of x is cosine x, the derivative of sine is cosine, and the derivative of tangent is secant squared. So plugging this in, we will get y prime equals f prime of x, g of x, which is cosine x, tangent x, plus f of x, g prime of x, f of x is sine of x, and g prime is secant squared x. And so we can do a little bit of simplification. This equals cosine x times sine x over cosine x plus sine x over 1 over cosine times 1 over cosine x, cosine squared x, sorry about that. Okay, so the cosines cancel, so we have sine x plus sine over cosine is tangent, so we have a tangent x over cosine, which is secant x. And that's our answer. So when you have complex functions like this one, trigonometric functions that are multiplied by each other, use the product rule to simplify, use the product rule to do a little simplification, and you get the derivative. Okay, thanks for watching. Don't forget to click subscribe, and then also click the little notification bell, leave a comment.